Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. In the previous video lecture we have seen the concept of bubble sort, right? So the example of bubble sort, program of bubble sort, and then special cases also we have seen in the complexities, why it is big O of n complexity in best case, that also we have seen. Okay, so now we'll go for insertion sort. We'll see what is this insertion sort, and of course the example programs and example. Then we'll go for complexities. Of course here also special case. In the name itself you can see insertion sort. So the list is divided into two sublists, of course sorted and unsorted. Here also you can see the sublist is picked up and transferred into the sorted sublist by inserting. Is that right? Inserting it at the appropriate place. Simply the insertion sort is like an element, what is the position of it in a list, so there it will be inserted directly. So many examples you can take in the pack of cards when you want to arrange according to the order. So a new card has come, you will check it out, what is the card and what is the position of that card. You can insert, right? If there is 6 and 9, if you get 8, it will be kept inside, in between 6 and 9. So if you got a card 10, so you kept at right of 9, right? So like this. Okay, if I ask you, like 10 people have there and they are they are standing according to their height. The 11th person has come and we'll check it out, what is his position, so where he needs to be inserted, right? So that is what insertion sort. And anyway we'll see the example, we'll see. And without separate function and with separate function, of course the two types we can see the code, okay, by using two for loops and if condition, and or if we can take by for loop and while loop. Okay, of course the complexity is same, but writing the code is different. Okay, we'll see that one, two programs, and then execution, then complexity. Of course here also a special case, that is how when it is big O of n complexity. Okay, best case and how it is we'll see. Here also it's same like in bubble sort. Okay, yeah, we'll see those things also. So we'll see, this is the original list. Now you can see the bar. I told you, no, sorted and unsorted. Now the bar, this black bar is directly after the first element, right? So your insertion sort will start from the second element. That's what you can see how it will be, you can see. So now this 78 you have to take first. Okay, this 78 you need to compare with the previous, what is that? Okay, so like this 78, what is the position? Is it before 23 or after 23? Definitely after 23. Why? Because 78 is greater than 23, so that's why 78 will be after 23. So now 23 and 78 are sorted, remaining list is unsorted. Now you can take 45. What is the position of 45? Where it has to insert? Is it left of 23, right of 23? That means in between 23 and 78, or right of 78. Now you can see 45, is it less than 78? Yes, true. So that's why this has to be shifted. Not only this, it has to be checked. 45 is checked with 23. Is that right? Now 45, if we check with 23, it's not true, right? So that's why 45 only has to kept here. So it will become 23, 45, 78. So like this. Now 8, what is the position of 8? Is it after 78 or before 78 or before 45 or before 23? So first I'll check with 78 and 8. Okay, so 78 and 10 satisfied, right? 8 is less than 78. Next check with 8 is less than 45, satisfied. 8 is less than 23, satisfied. Yes, so 8 has to be shifted here and all these elements are shifted to the right. You can see now what is the position, like this. Now 32 is checked with 78. Yes, true. Now 32 is less than 45. Yes, true. 32 is less than 23. No. So that's why position of 32 will be here only, right? So that's why you can see 8, 23, 32, 45, 78, and the last one 56. 56 is less than 78 is true. 56 is less than 45. No. So that's why position is here. So whenever the condition is false, then you stop there. Is that right? So this is what the insertion sort is. You can see here. Of course here also 6 elements are there only. 5 passes are required. If you have n elements, you require n minus 1 passes are required. So like this we have to go for insertion sort example. Okay, yeah, we can see the program now. So how to do this one? Anyway, I told you, like, if the index starts from 0, you have to start from 1 only. Why? Because for 0 there is no left element to compare. So for 1, so it goes to compare with 0. For 2, it will compare with 1, might be with 0. If not, okay, if here only not satisfied, it will stop here. Is that right? Like this. So now if you take this one, if you see the code here, right, so j starts from I. Okay, I starts from 1, j starts from that position only. If I is at 5th position, j also from 5th coming to the back, right? So that's why j value is decrementing, you can see. So j starts from I, and now you have to check it out. If it is less than, okay, so what this code is like, it is swapping every time. You can see it is like this. I'll go to the example. Let us suppose 8 is there. So 8 is checking with 45, right? So now what I'm here, yeah, 8 is checking with 78. Is it true? Yes, then swap. Okay, 8 will come here, 78 will go here. Now 8 is checking with 45. Okay, 8 will come here, 45 will go here. 8 is checking with 23. 8 is coming here. This is what the logic that is written here. Of course, another logic is also there. I will explain what is that logic means. I'll explain, I'll directly. So instead of swapping every time, I'll do like 8 is less than 78, just take 78 here. 8 is less than 45, take 45 here, like this. Anyway, that also I'll explain afterwards. So first this one is swapping every time, you can see, until it is false. You can see if a of j is less than, then swap. Okay, so like this. Next also like this, every time it will do. If not, immediately break, no need to go to the next. Let us suppose if you take this one, let us suppose if I take out something like where it is initially false, will take 78. Let us suppose 78. Let us suppose here 23, 45, 78 is there. Here let us suppose 98 is there. Is that 98 is less than 78? False. Directly goes to the else part. Directly goes to this else part, break, no need to do. Is that right? So this is what. So like this it will go. This is like swapping every time. Let us suppose if I take 32 78, swap. Okay, and 32 45, swap. 32 23, no. So that's why break. So this is what the logic here. Of course, without function here I have written. Here if you see, this is with function. I'm calling insertion function. Here you can see insertion function, the same code I have written. Else break, like this we can write, and we can execute also this one. And not only this, instead of writing like this, we have another way also writing this program. You can see here, this is a program too, you can see. So I starts from 1, that is also fine. I less than or equals to n minus 1, which is also equals to I less than n, that is fine. I have taken a temp equals to a of I, j equals to I minus 1, this while loop. So what is the logic here? It is written as, I told you, no. So let me take an example. Yeah, here. So what we have done, 8, if I take 8 and 78, okay, less than, then I swapped in the first program. But here I'm not swapping, I'm simply keeping this 78 here. But where is 8? It is in temp. It is in temp as it is. So here 78, here 78. Now what is the next one? 45. Is that 8 is less than 45? Yes, true. So that's why this 45 will come here. Okay, now next 23 is 8 is less than 23? Yes, true. So this 23 will come here. Now this is over. Now here I'll take the temp at the end, like this. This is also fine, right? Let me take another example. 32 is less than 78? Yes, true. So that's why 78 is here. Anyway, 32 is in temp, right? 32 is in temp. So 78 here. Now 32 is with 45. Is it less than? Yes, true. So 45 will go here. So next 32 is less than 23? No. So that's why stop here, and here you just keep 32. So this is like, instead of every time instead of swapping, it is like rotation. It is a concept of making rotation. It is like rotating the elements to the right. Is that right? So this is rotation concept, and this is swapping concept. This is insertion sort with swapping concept. Of course this is also swapping. This is with rotation. So like this also you can do, both are correct. So anyway, I'll go for execution of these two programs. First I'll go for this one, whether it will execute properly or not. I copied everything. Okay, you can take somewhat big value of array. Yeah, I have taken the array elements and I'm calling insertion function. I have written the same thing here, you can see. So if it is less than, swap, otherwise break. Okay, directly I have written, and every pass I am printing. That's why I have written inside the I loop. This one you can see. That's why I have taken k loop, k variable. I'm executing this one. I'll take something like 7 elements. Okay, 45, 32, 78, something like 8, 56, 97, and one more element, 42. So we'll see this one, the output every time. Yeah, after pass 1, that is 32 starts, 32, 45 over, remaining are as it is. Next 78, of course 78 is less than 45, no, as it is. Now the next one, 8 is less than 78, yes. 8 is less than 45, 8 is less than 32, yes. Next element 56 is less than 78, yes, that's why, and it's not less than 45, stop here. Next 97, okay, here only. 42 is less than 97, yes, true. Less than 78, yes, true. 56, yes, true. 45, yes, true. So will be here. So this is what, of course there are 7 elements, that's why 6 passes I told you, no, n minus 1 passes are required. So like this, insertion sort with swapping every time. And anyway, we'll see the another code also. This is a one type of code. Yeah, I copied this one by using while loop. Here you can see. So how it is, temp a of I, the value you are keeping, and this is rotation until the condition is false. Okay, yeah, this is a rotation until the condition is false, or it reaches to the initial index. Okay, and finally what is a of j plus 1, keeping in the position, that is rotation part. So we'll see this one execution. I'll take the 7 elements, 45, 32, 78, 8, 56, then 96 and 40. Now we'll see this one. Yeah, 45, 32. So 32, 45, 78 here only as it is, here 8 directly keeping here. Next the same thing, you can see 56 here, and 96 same position, 40 it has to go here. So like this we can go for insertion sort. So like this in 2 ways you can write. One is with swapping like this, and the another one is with rotation. Okay, hope you understood this one. Now the last one is complexity. What is the complexity of insertion sort? You can see. So anyway, worst case it has to go to the n, of course n square times 2 nested for loops. Okay, in the worst case it has to go big O of n square. Now for average also. Now what about best case? There is a best case exist here also, if the elements all are in sorted order. Okay, we'll take that case, how it is in all in sorted order. Let us suppose I'll take the elements here. Let us suppose I'll take the elements here, 10, 20, 30, 40, 50, 60, like this. Now let us suppose if I start from 20 and 10, is the 20 is less than 10? No. Is that right? So directly break, means this j loop will go one time only, right? So it won't go. Break means comes out of the j loop, I value 2 comes to 30. Is that 30 is less than 20? No. Again j loop one time, next one time, next one time only, one time, that's it over. So if you take 6 elements, only 6 times it is going. Is that right? So this is what, if you take n elements, only n times it is going when the elements all are given in sorting order. So how to check this one? Means I'll take a count variable. count initially 0, and whenever it reaches to else part, so I'll count it as C++. So finally I'll check it out. Okay, I'll check it out. So how many counts are there? So that count you can check it out. Okay, and if count is equals to the n value, then you can say that it is already in sorted order. So like this we can write anyway. So this is about insertion sort. So the complexity in best case is big of 1, and you can make these changes. I think you can get the output for this one also. Okay, yeah, this is about insertion sort. So now we have completed insertion sort, and we'll see the next one, merge sort, in the next video lecture, where in the merge sort, which is a best case, I mean the complexity is very good compared to the above 3 algorithms, above 3 concepts, especially in worst case also. Okay, so that merge sort we'll see in the next video lecture. Thank you.